Welcome back to math. These are the practice problems for section 8 on inequalities. Problem 1 asks us to show x greater than or equal to 7 on a number line. I've already drawn a number line here with 7 in the middle, and we go up a ways and down a ways. Remember that number lines go forever and ever to the left and to the right, but we just show part of them. So we'll start with 7. X can be equal to 7, so we're going to use a solid endpoint to fill in there. And then it says that x is greater than or equal to 7, so we're going to shade the numbers that go up that are greater than 7. And that would be our solution. Problem 2 asks us to show -5 is less than x on a number line. Well, we've been used to seeing x on the left-hand side of this, and I'm going to reverse that. So if I reverse this, remember that I've got to change the sign, change the direction of that sign, so that now we have x is greater than -5. Alright, here's -5. It's not equal to -5, so I'm going to have an open endpoint drawn, and it goes in the greater than direction, so it's going to go this way. There we go. X is greater than -5, which is also -5 is indeed less than x. Problem number 3 asks us to show -3 less than or equal to x, which is less than 2 on a number line. That's a compound solution, and in fact it's the intersection of these two conditions. The first one is x less than 2, just the way it looks there. And the other one is x greater than or equal to -3. You see, I've reversed this part here. I wanted x to be on the left-hand side. So let's start by drawing the first one, x less than 2. That means it's not equal to 2, so we're going to have an open endpoint here, and less than, meaning it's going to go in this direction. We don't know how far yet. We'll come back to that. So x is greater than or equal to -3. So it can be equal to -3. It will draw a solid endpoint, and it's greater than, so we'll go this way until it meets up with that part of it. So this section of the number line is where x is less than 2, and it's greater than or equal to -3. Practice problem number 4 asks us to show the union of x greater than or equal to 2 or x is less than 1 on the number line. So either one of these can be true. We're going to show all the examples where either are true. Let's start with this one. X is greater than or equal to 2. Alright, here's the 2. We're looking at positive 2 here. And it can be equal to 2, so we have a solid endpoint. And it's greater than 2. So it goes in this direction. And we also need to look at this problem. X is less than 1. Here's 1. It's not equal to 1, so we have an open-ended endpoint. And we go in the less than direction, which is going to be all the way down here. So we're going to shade way down. So this is the union of these two conditions. Problem 5 would like us to solve for x, where x minus 3 is less than or equal to 4. So we just need to get x all by itself, and x is having 3 subtracted from it, so we'll add 3. That does leave us with x all by itself on that side. 4 plus 3 is 7, so x is less than or equal to 7. If we can check our work, pick a number that's less than or equal to 7. Let's just try 4. Every time I see an x, I'm going to write 4. 4 minus 3, that's 1, is less than or equal to 4, and that's true. Problem 6 is going to solve 3x plus 5 is greater than x minus 1. Right, we've got x's on both sides of the equation, or both sides of the inequality, So I'm going to start by combining the like terms, and I'm going to subtract x from each side. That gives me just negative 1 here, and 3x's minus 1x is 2x, and we bring down the 5. Alright, now I'd like to get x all by itself on this side, so I'm going to subtract 5 from both sides. That will get 2x alone over there, greater than negative 1 minus negative 5 is negative 6. Now we need to divide by 2 on both sides because x is being multiplied by 2. That finally leaves us with x all alone on that side. Negative 6 divided by 2 is negative 3, and negative divided by a positive, signs are different, the answer is negative. So the answer is that x is greater than negative 3. Let's just check our work here. 3x plus 5 is greater than x minus 1. Choose a number that's greater than negative 3. How about 0? 3 times 0 plus 5 is greater than 0 minus 1. Every time there was an x, we've replaced it with a 0. 3 times 0 is 0. Plus 5 is just 5, greater than 0 minus 1 is negative 1. And indeed, 5 is greater than negative 1. Here's practice problem number 7. Solve 5x minus 2 is less than or equal to 12 minus 2x. Again, we've got x's on both sides of the equation. I can undo this part of it by adding 2x to both sides. That will combine the like terms. 5x's plus 2x's is 7x's, and I'm going to bring down minus 2. And these have canceled out now. So now this has minus 2 on this side, so let's do the opposite of subtracting 2, is to add 2. That cancels out, and we have 7x left on that side. 12 plus 2 is 14. Now we need to divide by 7, since the x is being multiplied by 7. We do the opposite. That leaves us with x on this side is less than or equal to 2. So we can check our work by choosing any number that's less than or equal to 2. In fact, we can use 2. So let's take every time there's an x, we substitute it 2, do the multiplication first, and 10 minus 2 is 8, less than or equal to 8. Well, in fact, 8 equals 8, so this checks out. Problem 8 asks us to solve 9 minus 3x is greater than 15. Well, let's start by getting the x part by itself on this side of the equation. That means we'd like to subtract the 9 from both sides. Don't forget to bring down the negative sign. That comes with the negative 3x, greater than 15 minus 9 is 6. Now we need to divide both sides by negative 3. That leaves us with x here, and 6 divided by negative 3 is negative 2. Signs are different, so the answer is negative. But remember, we also have to reverse the sign because we divided by a negative number. So we get x is less than negative 2. Let's check our work to be sure we did that right. I'll rewrite the problem. Now let's take a number that's less than negative 2 to substitute in for x. Let's choose negative 3. Alright, so negative 3 times negative 3 is positive 9. And 9 plus 9 is 18. 18 is indeed greater than 15. Problem 9 gives us 4 possible answers to the solution of graphing the inequality negative 1 is less than or equal to x, which is less than 4. Remember, we've got 2 parts to this. We've got the x less than 4 part, and we've also got the x is greater than or equal to -1. And we got that because if I want x to be on the left side of this part, I need to reverse the sign. Alright, so which one of these shows x less than 4? And remember, this is an and, so they both have to be true. Well, these A and B really don't show that. They show x being greater than 4. This one has a solid end point, so that's probably not right. So already I kind of like answer C because it shows x less than 4 with an open-ended end point. Let's check this too. X greater than or equal to -1. Well, on this, -1 is indeed filled in. That's the equal part of this, and it goes this way until it gets to 4. So C is the right answer. There's other ways to test these too, and I won't do all of these, but if you want to test to be sure that, say for example, 2 should be part of the solution set, you can test it and say 2. Is 2 less than 4? Yes. And is 2 greater than or equal to -1? Yes. So 2 definitely should be a part of the solution. And you can do that, and you can test all the numbers. You could test -1, test 4, and all of these ranges to be sure that you've got the right answer.